And welcome back. So I got you on tripod here, and we're going to cover a little bit of this while we're inside the garage because it's a bit easier to go through. But if you remember in the last clip, we were troubleshooting an issue where the front controls to raise and lower the windows weren't working for the front driver or the front passenger. Now they would work for the rear driver and passenger doors. You can lower and raise the windows fine, and if you want over to the passenger door, you could use the window button on it to lower and raise the window with no issue. So it's only not working from the driver's master set of switches. So we're going to go through the connections on what is called the door module. So besides just having that master set of switches, there's also what is called a door module. That door module is responsible for many things, to include, believe it or not, raising and lowering the driver's window, the functions in the rearview mirror, depending on which ones you have. It'll control the defrosting circuit, the turn signal, if you have a mirror with integrated turn signal. It'll also control the puddle light in that backup mirror as well. And it also is responsible for communicating. Actually, let's just go through it here. So that module has 5 connectors. I've just gone into all data and printed out the pinouts of all 5 connectors, and hopefully you can see that. Let me get you raised up here just a little bit. I got you zoomed in a little bit, but not too far, hopefully. So that, in our particular setup, that door module has 5 connectors, 5 utilized connectors. It has many more slots in it for connectors, but we're only utilizing 5. Let me get you straightened out here. There we go. So this is the first connector in that, and we'll go over all this when we're outside in the truck. And maybe you can see the description there. If I hold it closer to the camera, you can see that this first connector, what they call C1, driver puddle lamp, driver and return. So it's the puddle light on the rearview mirror out of this connector. It's also responsible for, there's your 5-volt supply to the mirror for that puddle light, as well as vertical position signal, driver mirror sensor ground, driver mirror horizontal position signal. So you've got a 5-volt supply coming out of this connector to the mirror. It's driving the puddle lamp in that rearview mirror, as well as it's got a sensor ground and 2 sensor feeds. One so it knows the vertical position of the mirror, one so it knows the horizontal position of that mirror. And that's the first connector. Second connector, called C2, you can see here in the description, if you had one, now you may not have one, but if that mirror has one, it's the driver heater, mirror heater driver, mirror heater return. So it's the heater circuit for that mirror. It's also the driver for vertical, common, horizontal. What that is, that's the driver circuit that actually moves the mirror vertical or horizontal, as well as a common between the two. And you see you've also got driver mirror turn signal driver, driver mirror turn signal return. So basically this connector is responsible for the heater circuit being able to vertically move the mirror, horizontally move the mirror as far as the driver circuit, and then flashing the turn signal light. Connector C3, now this one's interesting. We'll get back to this guy later, a little bit more detail. CAN IHS bus, CAN IHS bus, positive, negative. So this is your CAN circuit from your vehicle coming into connector C3, as well as a ground, fuse, battery, positive. Ground's going to go to a frame ground, or a cab ground, or body ground I should say. This fuse B positive is going to come straight off the TIPM that's inside the engine compartment. So the big fuse block inside the engine compartment is what's going to give your battery positive. So yes, this module communicates with the CAN circuit just like every other module or PCM or transmission control module. Everything in that truck talks to everything else across that CAN circuit. This module is no different. Connector C4. Driver window hall sensor A, signal. Driver window hall sensor supply. Driver hall sensor return. Driver window, hall sensor, signal, return, and supply. Driver window up, down. Now we're getting into the meat of kind of what we're looking for, or part of what we're looking for. If you'll notice, this doesn't say the master switch like we were talking about earlier. That master switch, when you're depressing up or down on the driver window button, that switch is only sending a signal to this module, and this module is the one that's actually running the window actuator up or down depending on how you're pressing that button. But you can see that there's your up, pin 4, pin 5 of that connector is for your down, and these are all sensors. And you'll notice it says driver window hall sensor. What that means is that motor unit, or that unit, has a Hall effect sensor in it. So the module can tell how far up or how far down, or the position of that window. And finally, connector C5. You'll see this here where it says LIN bus. Again, we're still talking about the module. Now this is another bus, but it's not the CAN bus. It's LIN bus. I'll explain that here in a second. And if you have it, memory select function, memory select switch mux, and memory select switch return. If you've got memory functionality where you can program settings where the mirror sets itself up a certain way and you want to return to that setting from multiple drivers, that's the pins that would be responsible for that. Again, some of these functions you may have, some of these functions you may not have. Now, the LIN bus, remember that. It's going to be kind of hard to see because there's a lot going on in this diagram. But what we're concerned with is this upper section right here where it says driver window motor, driver door module. So that's the module for all the connectors we were just looking at. And you'll see driver window lock switch. So it's the master set of switches that has the lock in it, as well as the up down buttons for the various windows in the truck. Now, earlier when we said LIN bus, remember, when this driver switch for the window, let's say you want to lower the driver window down, you're using the driver switch module. Remember, this doesn't actually drive the motor for the window. You see where this says LIN bus? If we follow these wires, I'm just going to use a green Sharpie here to grab this one. There's a couple of LIN bus wires here. We're going to follow this up, and hopefully you can see that. Hopefully that makes it a little bit more clear. So this master set of switches, it's got your windows and your door locks and everything on it, talks to the door module on its own bus. Again, not the CAN bus, because that's what allows this module to talk to the rest of the truck, but just communication between the door module and the master set of switches. So it's kind of interesting the way they've done this. So let me do this. Let me get you down here. I'm going to pause you and zoom you in, and bring you back. Yeah, because it won't let me do it while it's actively recording. So let me do that. Let me pause you, zoom you in, and I'll bring you right back. Okay, welcome back. So I've got you zoomed in as far as I can. And like I said, it's kind of small print because there's a lot going on in the diagram. But again, this door set of switches talks to the module on its own communications bus. And then you'll see these wires here. Remember, this is our motor for our window winder. So up or down, this is the guy physically doing the work. Guy or gal physically doing the work. And this is the module. So this module is tied physically, electrically, I should say, to this motor. Just to give you an example, let me highlight one of these lines so you can kind of see what I'm talking about. So interesting enough, when you depress this switch, it sends a signal to this module. This module then drives this motor. So why is this important? The reason why this is important is going to help us troubleshoot this. Because remember, the driver window and the passenger window are both inoperative from the driver's side set of switches. Now, I didn't show this in the first video, and I apologize, but remember in the first video, I went and grabbed another set of switches out of our red RAM just to give it a try. And we got the same result. One thing that didn't happen on both set of switches is that when I push the driver button, driver or passenger button, to try to lower the windows, you physically heard nothing happen as far as the window regulator itself. So we got a couple things going on here. Either this switch, this master switch, is not sending a signal to the door control module, or the door control module is not sending the necessary power and ground to actuate the motor either up or down. So it could still be the likelihood that the motor is bad. It's a possibility, but kind of less so until we test it, because not only is the driver window not working, but the passenger window is not working. And the interesting thing to note here, and let me see if I can find it. Remember, and let's see if we can see it here. Yeah, left rear power window. Now, interesting enough, if you look at how this master switch is wired, I'll just pick this diagram up here and kind of show you this. You see these here where it says rear window, left and right. We follow our diagram over of where they go, and you'll see there's your motor modules. It ties directly into the signal for the motor modules for the rear windows. So that's right rear, left rear, passenger side window, and passenger window motor front. That's what we're looking for. Now you'll notice, just like the driver stick, so keep that in mind, this set of switches, and the driver and master switches, are directly tied in one way, shape, or form into those drive motors for the rear windows. Now remember, our rear windows work fine. You can lower windows, you can raise the windows. But the passenger window, front window, does not. But look how they have the front window wired. The passenger front window, much like the driver front window, has its own door control module. That module, just like the driver window, is driven directly from this door module. And if we go back and look, we know the switch on the driver's side talks to the door module via its own bus. But how does this switch here talk to the passenger door module to tell it to raise or lower the passenger window? And if you remember, And you look at our wiring diagram here, the only bus you see coming out of this master set of switches is the LIN bus. That LIN bus right there only talks to the driver control module. But remember, when we went over our pin, driver door module, we went over our pin alignments for our driver door module, there's a CAN bus on here, which talks back to the main bus inside the truck. Once it's on that bus, it could then talk to the passenger door control module, which will then talk to the actual regulator or the motor for the passenger window. So keep that in mind. So if you're sitting on the driver's side, just to recap that for you, and you go to lower the front passenger window, it's got to go from this module, which is your master switches, to the driver door module via the LIN bus. And then from this LIN bus, it then has to ride basically talk to the CAN bus, which it's kind of hard to see, but I'll show you in the diagrams. But it's basically these two pins right here, and it gets onto the computer network of the truck. Using that CAN bus, it can then talk to the passenger front door module, which can then get it into the operation of the motor to actually raise and lower the window. So with that being said, this works, and this is our rear window. This isn't using a bus. It's able to communicate directly, electrically. So there's only one other piece of hardware besides this switch that can facilitate working the front driver or passenger windows, and that's that door control module. Now, we already switched out this group in the previous video that had all of our switches on it, and it was a no-go to either front window. And we know the motor is good on the front window because we can go over there and hit its switch directly from the passenger door, and it works fine. So we know the passenger door switch can talk to its door module, and the door module can obviously interface with the motor and actuate the motor without an issue. So what we need to test for is powers and grounds. One, making it to this switch. Now, we can go through the exercise and I'll be happy to show you this. But remember, the rear windows work. So that's pretty much going to tell me that this master set of switches is getting correct power and ground. Now we need to verify power and ground also to the driver side door module. But remember, this driver side door module is also controlling all the features of our rear view mirror. And when we were testing our lights earlier in previous videos, we could see that we have a turn signal marker in the mirror. We could see that we have puddle lights. So that tells me that this module is getting power and ground and CAN communications, because when we hit the hazard lights or turn on the just running lights, the driver's side mirror is working correctly. Now, with that being said, when we did the scan tool on this truck earlier, very first on, if you remember, straighten you out here a little bit, there we go. Remember, one of the faults we got was for the driver side door module, loss of communication. So what we can do to do our due diligence is that we'll go out there and we'll verify power and ground, verify that's good to that door module, and then we can also test power coming out of this module into the motor, into the basically the motor or the motor control for the driver window as we activate the switches. And if we see power coming out of here telling the motor to move, but the motor's not moving, then we know we're looking at potentially just a bad regulator, and we need to get the assembly and just replace it. Now that is a possibility, but the likelihood that it's going to be a bad motor, maybe 50-50, because again, the passenger window is also in op. So what we may run into is a problem with this door module, because remember, it's got to communicate across that bus, be able to tell the passenger side to raise or lower, but it uses its own internal LIN bus, as they call it, if you're just doing the driver's side window. So with that being said, and I know that was a lot, let's see here. We are looking for, so again, there's our C4 connector. So we'll be testing pins 4 and 5. And if we look at 4 and 5, there it is. There's ground. There's ground. There's fuse, battery positive. Okay, got it. Yeah, pin 4, pin 5. Yeah, up, down, supply, common. Okay. So we can use this pin out here, or this schematic, along with these pinouts to help us test, that we're at least getting voltage where we need to get voltage. Now, being able to look at the actual CAN signal, I don't have something to graph and see that. I would need like a single channel oscilloscope, or like an automotive voltmeter, so something that could at least show us something of a waveform so that we can see that the bus is active. Because it could just very well be that there's something wrong with this LIN bus. So when you're telling it to work the front driver or passenger windows, it's not communicating on this LIN bus to tell this module to behave accordingly. But it would explain why the rear windows work, because again, it's not using the door module, it's not using this module, the module communication, this LIN bus, to tell the rear windows to go up or down. It's able to talk to the motors directly, or to the switches directly, to close the rest of the circuit on the rear half to get the windows to do what they need to do. So to me, it's looking like we got a potential issue with the LIN bus, which is again the communication between the master set of switches on the driver's side and the door module on this side. But we'll go through, we'll verify our powers and grounds and make sure that our module is working correctly, or at least to the best of its current ability. C2, C3, C4, C5. So we don't really care about the driver mirror. That's more driver mirror. This is our CAN bus. So there's what we'll do here. To verify power to our module, we'll come to our connector, C3, pin 4, pin 5. We should have ground on pin 4. We'll verify that's a good ground. And our pin 5, we should have battery positive. If we have that, that'll verify that we're getting power to our module. And here's the connector that we can use to verify that we may or may not be getting power to our window. As you'll notice, pin 4, pin 5 of that connector is significantly bigger. So those are going to be your current carrying wires. As they show pin 4, you can see that there, pin 4 and pin 5 are either driver window up or driver window down. So what it's doing here is it's just reversing the polarity on pins 4 and 5 to dictate whether the window goes up or down, and then it looks at the sensor output to determine the position of the window. So we should be able to meter probe or voltmeter probe pins 4 and 5 as we actuate the driver's side button and verify if we're even getting voltage out of our module. And if we're not, if we see good voltage coming into the module but no voltage going out, then that tells me either something's wrong with the driver circuit in the module, or something's wrong with this communication between the switch and the module. Therefore, it doesn't see a signal to tell the window to do anything. So that's what we got to check. So long-winded explanation. I apologize, and this will make a lot more sense once we're out there and we've got a voltmeters and everything else hooked up to it, and we'll step through it. Now, if it is the module, and I did research this a little bit ahead of time, I apologize. The module, the front left-hand, so left-hand driver's side, door module, the original door module is discontinued, aka no longer produced. Unless you can find it somewhere, you can't get it from Chrysler. However, after digging through a couple more Chrysler parts websites, the original part number crossed to a new part number. That part number was also discontinued. That part number crossed over to yet a third and new part number that is still available. So just kind of thinking ahead of time, I went ahead and ordered what the current part number is supposedly for the front driver's side door module. So hopefully, like I said, hopefully it still works. Because again, the original part number discontinued. Came up with a replacement part number. That replacement part number again also came up recently discontinued and replaced by yet a third part number, which is still active in the system. So if we get in here and we diagnose this, and we, like I said, we diagnose that we got good power, we got good ground, but we're not seeing voltage output to the window motor itself, then that'll tell us that either the module's bad, or we got two sets of bad door switches, which is possible, kind of unlikely, but possible. Or we just got a bad LIN bus here on this door module. That being said, I'll go ahead and stop this segment at this point, and then we'll get, once we're set up out there and we'll get ready to test this, I'll bring you back. Thank you much. And welcome back. In the previous segment, we were looking at our connectors for our door control module, and we were verifying what the pins were and what we were going to test. And the first thing that we wanted to look at was powers and grounds. So what I have here is our meter on continuity mode. If you remember, continuity mode in this meter's case will give you a tone. So for example, one part of the meter is hooked up underneath the dash onto a piece of metal, which is grounded to the body ground. And if I grab the other side of the meter, which is hooked up to this lead here, and let's say touch it to, let's find a good piece of metal, there we go. So the bolt coming out of the door here, or this bolt going on this door here, so that lets us know that the door has got a good connection to body ground. And we know that the body ground is tied into the frame ground already for some previous testing. I also printed out two more connection diagrams, C1 and C2, for what is called either, it's called a couple different names. This is either called a master set of switches or driver's side door lock / window switches. And looks like we get battery positive, looking at this diagram here, off the C1 connector pin 1, but we want to verify grounds. So if we look at connector C2, which the smaller connector in this case would be C1, you can tell by the picture there. The larger connector is what they're calling C2. So if you look at C2, it says pins 5 and 13 should be grounds if we have them. So pin 5 on the connector and pin 13 of this bigger connector. And it says pin 1, you can kind of orient yourself with the connector. So 1, 2, 3, 4, 5. It should be third from the right, depending on how you have the connector positioned. So let's take a look at that. So in the diagram, they've got the release tab basically facing this way. So what we can do is that we can actually just take it out of here, because as long as it gets up to the pin, I'll have to forgive the camera work, because I'm going to have to struggle with this a bit to get this release to let go. There we go. And I'm going to go ahead and take our LIN bus or battery positive connector off as well, just so it's not dangling here by its connector. Go ahead and take our, that's our original door control switch / lock. If you remember, by looking at our diagram, it had the connector positioned this way and said it was pin 7. So 1, 2, 3, 4, 5, 6, 7. It was 7, I'm sorry, pin 5. 1, 2, 3, 1, 2, 3, 4, 5. So it should be that third pin in the center group top. So that should be tied to a ground. So if I probe it, then we should get a tone. Again, kind of hard to do when you need 3 hands to hold camera in position here. You have to forgive me, I'll have to probe this. There we go. So you can see we're in our connector there. You can hear the tone on our meter. So that's letting me know that we have ground continuity from pin 7, but there's also another one, pin 13, which, looking at our diagram, is right here. There's only 2 pins we have on the bottom of this diagram. Looks like we've got pin 8 and pin 13. You can tell the far right hand side is 8 and the one before the end is 13. Again, I'm going to pin this. You're going to have to forgive the camera work. It's hard to kind of keep all this in the shot and hold this connector, but I might be able to get it. There we go. So that verifies on our main connector coming into our master switch / door lock window, options, whatever you want to call this, or I should say call it master switch or just driver's door switch. That verifies that both our ground pins that we should have are valid. We're getting a good ground up to this connector. And we want to do the same thing, if you remember, to the door control module. And if we remember correctly, that's a sensor ground. Not really looking for sensor ground. There we go. So that's what we're looking for here. We're looking for the C3 connector because it's got our battery positive and our main ground. And how you find the connector C3 on this one is a bit easier because they're actually numbered. And hopefully you can see that. So it starts here at 1, 2, 3, 4. And it goes over here to 5, 6, 7, and 8. So you can see there's provisions for 3 more options to be plugged in, but in this case, this one doesn't use it. So what we want is connector C3. Let's go ahead and get that one out. And per this one, just like in the diagram, you can see that the 2 top ones, the 2 bigger pins, and it's even color coded nicely for us here on the back of this connector. You see we've got a red with a green stripe and a black one. And what it's telling us is that pin 5, which if we orient ourselves to look like the connector's facing and have this end up, this little tab off to our left, then pin 4, which is this one here, left hand side, matches up with our black wire in the back, should be our ground. So let's test that. And there we go. So that verifies that we've got a good ground to our door control module and to our set of switches there. So that's been verified. The next step would be to hook up some power, put the key in the on position, and then test make sure that we're getting good battery positive to our opposite lead on this one. And if we go back and look at our door switch, battery positive is actually on connector C1. Remember the smaller connector, and it's pin 1. So we're looking for pin 5 on our door module to have battery positive, and then we're looking for pin 1 on our door connector here, which if we orient ourselves per the diagram, provided the diagram is right, it looks like we want pin 1, which is this far pin all the way towards the end, which looks like in this case it is green, and that will be our battery positive. The rest of these, which is, let's see, LIN bus return is pin 2 according to this, which we have. Pin 6, which is below that, is LIN bus. So you got a LIN bus pin, you got a LIN bus return pin, which is pin 2. And the reason why we don't have a pin 3, you'll notice it says pin 3 is LIN bus. Well, that's only for a standard cab. We have a quad cab. So LIN bus is actually on pin 6 for us on that connector, not on pin 3. So it's just kind of things you have to keep in mind, that in this case, if we were wanting to test the bus, it would be on a different pin just because of a different trim level of the vehicle. But again, what we're concerned with is pin 1, which again on this little connector is right there. It's a really, really small pin, and you can sometimes probe them from the back a bit easier than you can the front. Again, just be careful when you're pinning these. I don't think my pin, yeah, I'm gonna have to get a smaller diameter probe in order to get into that one. But while we're here, let's look at this one. Yeah, that one we can definitely touch with the current probe that we have. That'll be no issue getting in there. So let me go get a quick power supply, get a little bit of power up to this vehicle, and then one additional probe, and I'll bring you back. One moment. And welcome back. So I just want to show you that we do have power to the truck at this point, or at least temporary power. And we've got a meter still connected to the ground that we were testing with. And then I'm going to test the positive, remember, on the door control module first. And see if I can set you up to look at the meter as I do this. Okay, there we go. So I'm going to hit that pin, and we should get 12 volts. We do. That's the voltage we're getting out of the jump pack right now. It's a little low, but you can see we're getting 10 volts on there. So we've got good power and we've got good ground to our door control module. So now I'm going to probe what is supposed to be plus 12 on our door switches. And let's take a look there. So it says pin 1 should be fused battery positive, and pin 1 should be our green. Let me can see we don't have anything. And I know I'm making contact with the pin. We should have battery voltage there, and we do not. So what we need to do is look up on our wiring diagram what fuse this connector here is tied into. Is it the same fused power we're getting for our door module? And if that's the case, why are we not getting our fused battery positive on here that we're looking for? Because again, if we go back to our door switch here, we've got this ignition runs, that's just a control output, that's a control output, that's a ground. There's another output here for ignition run accessory control output, but you see the only other thing that's left is left and right window. And remember, these switches tie directly into the switches on the rear, which is why when I do this, even that one has no power to it right now, you see the back windows still work. So it looks like the reason why this module is not communicating with our door module to tell the windows to do something is that we do not have plus 12 volts or battery power on this number 1 pin. And that's going to be our next step, is to look that up in the wiring diagrams and find out why. With that being said, I'm going to go trace this down the diagram, and we're going to locate a fuse, and I'll bring you back. Thank you much. And welcome back. So we're back looking at our main wiring diagram. And what we're trying to trace is, since we know we're not getting 12 volt battery positive on this fuse like we're supposed to, then where does this connector, this pin 1, get its power source from? And if we follow our wiring diagram, this is going to be kind of hard for you to see, and don't worry, I'm looking at trying to get some capturing software so I can actually do this on a PC and show it to you where you can see it. But if we follow pin 1, battery positive, over, up, you can see that it has a separate power feed that's different than the door control module, because you can see its power feed coming off its pin here, going up and going in. So the door control module gets its power feed from, looks like it's fuse J7 in the TIPM, and what we're looking for is the main set of switches and door lock module come up, it hits the TIPM, and it says it is M25 10 amp. Now this is the non-OE diagram, so kind of take it with a grain of salt, but M25 10 amp. I pulled M25. It is a 10 amp fuse under the hood, and hopefully you can see that. See that little dark spot off to the right of that fuse? Let's test this. I think we're going to find out that this is blowing. And hopefully you can see that there in the bottom of the fuse legs, but you'll see some discoloration there as well. These legs got hot. So let's get you set up outside here so this will be easier to see. So let's get you in on the meter. I'm just going to grab myself an alligator clip to make this process a bit easier. In case you're wondering what I'm doing, I'm just putting alligator clips on the test leads so we can hook up directly to the fuse. Going to turn our meter on the continuity. Going to test it first, and this is our fuse in question. Look at that, nothing. Fuse is blowing. So I've got a replacement fuse here. Let's just test it before we put it in. And we're good. So I'm going to go put this replacement fuse into our fuse box, and then we'll give the vehicle power, come back here, verify that we got our battery voltage on our pin now and go from there. Now, does this end things here? If it works and doesn't blow the fuse again, yes, then we can maybe chalk this up to being some type of one type event, or maybe an aftermarket accessory the individual had on the truck blew the fuse. But fuses just don't blow for the sake of blowing. Something driven into overcurrent. So we could replace this fuse, and if it blows again, then we could very well have a problem with this master set of switches up here just drawing too much current, or a short in the wiring or the system somewhere. Now remember, we did repair a bunch of wiring bundles underneath the dash there, so you know, anything's possible. But we know we got blown. We know we were able to check again our powers and grounds, tracked it down to a bad fuse. Let's get that bad fuse replaced and we'll go on to the next step, but I'll bring you back in a bit. Bye. And real quick, right before our jumper pack dies, let's see here. So I'm going to get you set up to look at the meter, and then we're going to probe. I still have the key off, but we're going to probe that pin 1 on that connector that we weren't getting power on before, or a battery positive on before. You can now see that we are. So I still have this connector unplugged at this point in time. And what we can do next is, and I may have to have the key in the on position to do this, but now that we have that module in there, yeah, I gotta have the key on before I can attempt to, but let me show you this one. So that's already a change. Before, when we did this, there we go. Before, when we did this, you can see how those LEDs are now working for selecting left and right mirror, and I forgot to show you this last time. That wasn't working, but now it is. So now we verified we're getting 12 volts to our door switches, which means the LIN bus between here, the communication between here and our door module, should be working. So now if I go get the key, put it in the on position, hopefully we can roll up and down the driver and passenger windows. So let me go grab the key and I'll bring you right back. Okay, real quick, while I still have power, watch this. Oh, interesting. So we may have a Hall effects problem yet. Watch this. See how it rolls the window down a little bit? Shouldn't be doing that, but it is. But you can see the passenger window is now working. It may just be low power from the jump pack too. There we go. Okay. So now that we got our windows rolled back up, there we go. Okay, so now it's in. So yeah, it looks like it was just weak power from our jump pack, but we'll come back and test this again because it was kind of acting a little jittery. But you can see now that everything is working. We can roll the windows down now. Let's see, can we lock and unlock? Oh, oh, still can't do that. So we got something we need to look into. That should prevent you from rolling up or down the window. Uh-oh. Uh-oh, we may have blew our fuse again. Yeah. Let's go back and let's go out there and check it. Let me pull that fuse. Actually, let's go pull the fuse together. So it worked momentarily. It feels like it may have blown. No, fuse is good. I think our jump pack is just in the process of dying. Let's put our fuse back in. Okay, so we got that there. Our jump pack is still kind of barely hanging on. It's getting pretty drained. It's probably going to cut out on us. Let's pull this connector and verify that we still have power. what I'm using here, because I needed a really thin probe to get into that pin, so just be careful if you're doing this. I'm just using a section of bread tie, because in a bread tie is a pretty stiff wire that's bendable, but it's also really, really, really thin. And when you're probing the front of the connectors like this, just be extremely careful with what you're doing. Yeah, so you can see we're down to 7 volts. We still have power here, but we're down to 7 volts. So that explains kind of our erratic operation, is that we're well below operating voltage for a lot of stuff inside this truck. So what we want to do is go ahead and shut our jump pack off. Get that guy out of here. And then what I'll have to just start doing is, this jump pack is a couple of years old, and it's getting fairly weak for doing stuff like this. So we'll just have to get a stable source of 12 volts in here. But to recap what we did, we started out by looking or diagnosing what our problem was, which was we could roll down the windows in the rear, but not front, left, or right. And upon looking at our wiring diagrams and kind of learning how the circuit operates, when you, on the drivers, using the driver's master set of switches, roll down the back windows, these switches, wiring wise, are physically tied into the actual switches on the back, which explains why those would work, because it's just a mechanical switch for the rear windows. To do the mirror adjustments, lock and unlock the doors, roll up or roll down the windows, requires communication from here, because those functions are controlled, and just some of those functions, I should say, are controlled by this door control module. So this door control module, if you see our wiring here, has a separate pigtail that goes up just for the rear view mirror. So all the functions in the rear view mirror, like the puddle lights, the turn signal, moving the mirror, horizontal and vertical, and if you had the powered mirrors that would automatically fold out when you put the key in ignition, or fold in when you take the key out of ignition, that would also be in control of this module as well. But remember, we were coming back and looking at our problem is that, all right, fine, we couldn't do passenger window, but we could do the back windows. It's like, okay, great. So looking at our wiring diagrams, we discovered that this module, unlike when it does the back windows, doesn't necessarily control the windows directly. It controls it by telling the door modules on the front passenger or front driver or front passenger to actually control the regulator. So knowing that, the next step was to check powers and grounds. Were we getting power and ground to our appropriate plugs here? Were we getting power and ground here? If you remember, we checked our ground here and it was good. We checked our 2 grounds here and it was good. We also then checked our power. We had battery positive here, but not here. And then per our wiring diagram, remember, the door control module got its power from a separate 25 amp fuse versus this set of switches here, which got its power from a 10 amp fuse. So we went out, checked in the port of this diagram. We verified M25 was a 10 amp. It was there and it was blown. We checked it, verified it with a meter, verified that our lovely fuse here was in fact dead. You can see it visually, and we tested it via meter. Replaced it with a known good fuse by testing the fuse. Came back here, verified that we now have 12 volt power to our module. One of the other things we noticed is that now that we have 12 volts, when we hit left or right mirror, we can select them. The LEDs come on. And when we tested this earlier, we were able to roll up and roll down the front driver and front passenger windows at this point. Now we'll test the rest of the functionality when I can get a decent power supply in here that can handle the amperage, because you're just, windows are a pretty good amp draw, if it gives you an indication. Again, just to show you the module. Again, remember, the module runs the motor, and the module has a 25 amp fuse. associated with it. So that kind of gives you the idea of what power draw it takes just to roll up and roll down a window. Which is why when the jump pack was weak and we were pulling all this power, you saw it kind of behave erratically. It was because the jump pack was getting weak. It had a big current draw on it. The voltage was dipping, and you know, let's just say computers and control modules don't like it when voltage dips. So the lesson to be learned here is, at least for myself, is that if you remember, I spoke yesterday when we were going over the wiring diagrams, and I commented that I went ahead and bought this door control module. And originally when I looked this up, remember, it was discontinued, replaced by another part. That other part also got discontinued, replaced by a third one. Now, looking at the wiring diagrams without doing any testing, I thought for sure it was this module that was dead. And without coming out here and testing, which I should have, I went ahead and purchased this module. So it led to an expense I didn't necessarily need. Now, with that being said, this module could go dead in the future, which in that case, we'll have a spare one on hand to be able to switch it out with. But just to give you an idea that coming out here and doing simple power and ground checks and verifying you're actually getting what you're supposed to be getting and the modules have power to work, it would have avoided me buying unnecessarily a module. So, you know, again, learn from my mistakes. But like I said, we will keep this module around. We will keep it around for a spare. And I will end the video with this one. I'm going to make another video, and just to give you an idea, this is the newer type design. You'll notice that says auto and that says auto. You'll notice that one does not. Don't worry, this is the one we took out of the 2012, so it's a slightly newer version. This is still the same part number, and I did look that up last night. In case you're wondering earlier when we tested this and it didn't work, remember, it wasn't because this was the wrong module, because this part number is the same part number between a 29 to 2012. Remember, our issue was that we weren't getting power to this set of switches here. So with that being said, we'll cut the video at this point. If you found the information useful and you haven't already subscribed, please consider doing so. Again, still working on growing the channel. I've got a channel member that is actually working on a set of graphics for me. It's very, very generous for this individual to do so. Once those graphics are complete, expect to see some, you know, changes to the channel, like to the icon and stuff used. Like we spoke about earlier, just trying to get the channel where it looks a bit more professional and a bit better done. I am not good with graphics nor Photoshop, which is why I reached out, and I had I've got a generous channel member that has been emailing me and giving me some samples and stuff to look at and kind of go off of. So hopefully expect those changes soon. Once he, or I should say the individual, is happy with the way the graphics look, then I'll start adding those to the channel. Again, they're creating them. I want to make sure they're as much happy with them as I am, you know, before the public sees them. With that being said, if you haven't subscribed already and you find this content useful, please consider doing so. Again, still just trying to continue to grow the channel. I'll call this video at this point because we're getting rather long. And then what I want to do next is take apart the passenger door, since we know that the door control module controls all the aspects of that mirror. Remember when we were doing our testing earlier, the lights, the turn signal lights and the puddle lights worked, but they were really, really weak. And this module contains the driver to drive those LEDs that make up that turn signal and that puddle light that's inside these mirrors. So either it's a bad connection within the mirror, or it could possibly be a bad connection here, or a weak set of drivers in this module. So what we can do is that we can pin it, we can figure out what the voltage output to those LEDs are going to be, simulate that with a bench power supply, and if the intensity reverts to normal, then we know that we've got an issue within the module somewhere. And unfortunately, the passenger door module is different from the driver door module, just because the functionality is different within what it's doing. But with that being said, I will let you go at this point, and I thank you much. Bye.